In this lesson, we're going to do one more equivalent polar coordinate kind of a thing. We are trying to name two pairs of polar coordinates given a rectangular coordinate of -2, 2. And we're going to lock our angle between 0 and 360. If we went -360 to 360, then we can do four pairs. But we're just going to go 0 to 360, so it narrows it down to 2. So here is our rectangular coordinate. First thing I think of is I'm just going to plot the point. And then I'm actually going to do some old trig stuff, some basic SOHCAHTOA things to figure out what the radius and what the theta is. So I'm going to plot the point. 1, 2, 1, 2. So my point is here. So that is your point in rectangular coordinates. So you went left 2, up 2. But here's where the trig part kicks in. So I start now realizing that I have a triangle associated to this. So I'm left 2 and I'm up 2 for that coordinate. What I need is the radius and I need theta. So it's just basic trig kinds of things. So if I'm going to figure out the radius, I'm going to just basically do Pythagorean theorem. Some of you might recognize that we have ourselves a 45, 45, 90 because these two sides are the same. The only difference is there's a direction associated with it, but it's basically a 2, 2. And so if you remember that, you're looking at an x, x, x root 2 kind of a look. You don't have to remember that because you could very much just do Pythagorean theorem on this. So you could do Pythagorean theorem and get 2 squared plus -2 squared. So the leg squared plus leg squared equals the radius squared. So that's 4 plus 4 equals radius squared. 8 is your radius squared, square root. You have a perfect square of 4 that you can break off of that with 2 left over. And so you're looking at your radius to be 2 root 2. And then if you did SOHCAHTOA types of stuff, you would find yourself with a 45-degree angle here. Now 45 degrees is not the answer because your angle is actually here that you want. 45 is your reference angle, yes, but not your overall angle. So our coordinate is, we have a radius of 2 root 2, and then we are 45 degrees, so 180 minus 45 gets us 135. Now, they were looking for 2. Well, that's that direction. So because we want to lock our angle, I can't go this direction. That would be kind of an obvious one. But I don't want anything, I don't want negative angles. So my other option is actually to have plotted this point on the other side. So that point, and then reflect it over. So essentially we're looking at -2 root 2. So -2 root 2 would be us reflecting it over. So how do we get to this angle? Well, your line here would be there. And so your angle measurement is still the same reference angle of 45. But it's not -45 because again we don't want a negative angle, so we're looking to go all the way around to there. So we're looking at 315 degrees. So if you go 315 degrees and then you're out that distance, but now you apply a negative, it's going to reflect it over to the main point that we're looking for. And that main point is supposed to be the rectangular coordinate of -2, +2. All right, so that was naming two different pairs of basically converting a rectangular coordinate to a polar coordinate, which is just basically draw a picture, create a right triangle, and do some trig to figure out what your radius and what your angle is. And then if they want some other things to it, you got to consider reflections, you got to consider what your restrictions are with your theta.